Hey YouTube, welcome back to part 8, and today we'll be moving on from the Inverse Kinematics mini-series to create an over-the-shoulder aiming system like you'll see in many third-person games. This has been suggested by Grant Christie, so give him a quick thanks in the comments if you feel this video has helped you. If you haven't seen the custom IK mini-series, I recommend you check it out, because I guarantee that you'll learn a lot of cool stuff there. But on a side note, the IK system that we built won't be used for a few episodes until we start adding more weapons and objects. Today's episode should be very simple, and I'm sure you'll learn some useful things along the way. I have received a question from Lobsang White a while ago on creating a player offset to the side, like in many third-person games, while preserving the collision, which I will also be teaching very quickly in today's episode. It's going to be very feature-packed, and you will need Blender or any 3D modeling program with animation capabilities to follow along, because we are going to be making a few animations just to get started. Just a quick announcement, tomorrow is the Ludum Dare 41 and I will be participating and making a time-lapse of my entry, so if you want to see that, just stay tuned to this channel. But like usual guys, make sure to comment if you have an idea, because even this video was from a suggestion. So if you comment, I will add it to a future upcoming episode. Also, don't forget to subscribe to keep up with this awesome original content, and without any further ado, let's get right into the video. Alright guys, I'm going to quickly get into this video. So this is where we left off last time. This is our inverse kinematic system. We're just going to go through and delete everything. You can keep it if you want, just save it into a prefab, that's up to you. But I'm going to delete it to make sure everything is nice and neat. So let's go into Centroid and just make sure that the root IK script is disabled. So the first thing that we're going to do is go into the models, and I'm just going to delete this. This is from the previous 10 recordings that I've done. And we're just going to double click our model and open up Blender. Okay, so the first thing that we're going to do is we're just going to change this mesh just a bit. So let's go into top view and let's just rotate it like it's holding something. It doesn't have to be perfect. I don't want to add new bones because that adds unnecessary complexity towards the model, but we will later. I'm just going to rotate it for now to make sure it looks like it's holding something. Okay, so once we've done that, all I'm going to do is select the armature and the mesh, go into top view and hold control and move it 4 units in the other direction. So 1, 2, 3, 4, and we'll just do it one more time. Whoops, sorry. 1, 2, 3, 4, 5. Let's move 5 units. So we have a 4 unit gap between the origin and where it is now. So let's duplicate this and move it back to its origin. So the way I'm snapping it to the grid is by using control. So I'm going to do this again, move it 5 units to the other direction. So 1, 2, 3, 4, 5, and RX 180 to rotate it 180 degrees to this direction. So let's save this, go back into Unity, and we should have a different arm model here now. Let's just go into console, clear this, and let's drag in the arm model into the centroid. And as you can see that it has been parented quite nicely. So let's just decrease the size to make sure it fits nicely onto the player, and let's go back into Blender. Okay, so all we're going to do now is going to create 3 different poses. Okay, so let's just go into the animation, let's go back into top view and orthographic mode, and let's begin animating. So to animate, let's create click this little record button and select available. Okay, now when you go into pose mode on the armature, hit A to select all, and let's just hit R, and don't move it, just click it, so it will set a few keyframes for this armature. Let's do the same thing for the other armature as well. Go into pose mode, A, and R, and that should create all of our little keyframes. So all I did was select A 2 times to select all the bones in the armature and hit R, and then just click without moving it, and it will create some blank keyframes. So the first thing we're gonna do in the first keyframe is we're gonna rotate this inwards until it looks like it's clasping a gun. So let's just see this in the model view, and that looks quite nice. This is the view that will be rotating the actual arm from when we are aiming. So we could just maybe move this out a bit more. Actually, no, this is fine. Okay, so once this is done, we're going to create the idle pose. To do that, first we have to select all of these keyframes and duplicate it. So let's just move it, let's say, just about 100 frames. Let's go back. It doesn't really matter how far you duplicate it, but we just need to make sure that it's duplicated, okay? So let's go past that frame, and all we're going to do now is we're going to go into this view, and we're going to rotate downwards, because this is going to be where the idling position is going to be. We're going to do the same thing for the other arm as well, just make sure it's lined up with the other arm, and we can see that we have two arms that go into idle position. So we're just going to make all of the animations in this one timeline, and then we'll extract them in Unity. There are different ways to do this, but this is the most simple way to do it. I just want to teach you guys how to do over-the-shoulder aiming, but you guys can use your own models, animations, anything that you want, okay? So now that we have an idle pose, we're just going to select the idle frames, duplicate it so we have a nice region for the shooting, and a nice region for the aiming. Now we have one more little state that we want to create, so let's box select all of these using B, duplicate it, and bring it past the idling point. And let's go into the middle of this, anywhere in the middle, and we're just going to go into this view, and we're just going to push the arm back 2 units. I'm going to repeat this for the other arm as well. And what we have here is a nice little recoil animation. So if I play this, we have a nice recoil, and that looks quite nice. We'll speed it up in Unity, so don't worry about that at all. So we're just going to save it and go back into Unity now. So open up Unity and wait for this to import, and we can see that our first shooting animation has already been attached. So first thing that we're going to do is go into scripts, and we're going to create a new folder, and we're going to call this folder aiming. And we're going to create a new animation controller. So let's go into this animator controller and just call this aim controller. And I'm sorry if I'm rushing through this, but I just want to get this done quickly because 1 hour videos aren't that fun to watch. I want to make this as short as possible. So let's just drag in this aim controller into this controller area over here, and then let's begin the actual extraction of the animations. Okay, so let's go into where we saved the model, and let's go and extract the animation. So we're just going to click this little plus icon under the animations tab when we select the model. So just let's click the plus and create the name of shooting. And let's create another one, and let's call this idle, and another one, and let's call this one fire. Okay, for shooting and idle, we need to make sure that the loop time and loop pose is set to true, so that they can actually loop seamlessly, and we're just going to select the shooting region. So to do this, let's just to bring this up so we can see what's happening, and let's move this back, and we can see this point is where we actually shoot. No idling animation here, so this is the shooting point, and let's just click apply, wait for that to load, and let's go into the idle, and let's select the idle point where it's completely in the idle stage, which seems to be here. And let's just select apply over there. Okay, now let's go into the fire. This needs to be a bit more specific. So let's just go near where the motion of the recoil starts and just before the motion of the recoil ends. So around here. That seems about right. So we're not going to loop time loop pose on this one because we only want the user to click every time you want to run the animation. You don't want the user to hold it and repeat it, okay? So let's just select apply, and now let's go and create our animation controller. So just go into aiming, double click on this, and let's begin creating our states. Go back into the models tab, and let's bring in all of our animations. First we want to bring in our idle animation, so that becomes the entry. And then you want to bring in the fire, and then the shooting. Doesn't matter which order after that. So I'm just going to create a very basic state machine right here. So I'm just going to create a transition from idle to shooting, shooting to idle, shooting to fire, fire to shooting, and fire to idle. Not idle to fire, because idle to fire we can't do that. We only want to fire when we're shooting, okay? So let's just do this now. So fire to idle needs to be when firing is true. So to do that, we're just going to create two integers. So we'll call this state and firing. Okay, and what we're going to do is when state is equal to 0, it is idle, and when state is equal to 1, it's shooting, and when firing is equal to 1, we're firing, and when firing is equal to 0, we're not firing. So using those things, we can create a quick little condition tree for us to follow. Okay, so for conditions from fire to idle, let's keep the exit time, make sure that the exit time is both on the fires, and let's actually select every other arrow that has nothing to do with firing, and just disable the has exit time. So this has no exit time, no exit time, no exit time over there. Okay, now let's go into the transitions and just bring these transitions down because we want to quickly move from fire to idle or fire to shooting, and we don't want too much transition. Okay, so we're just going to bring that down a bit. Okay, nice. Now from fire to idle, it happens when the state is equal to 0 and firing is not equal to 0. Sorry, not equal to 1. Okay, easy stuff. And when fire is not equal to 1, and sorry, when state is equal to 1 and firing is not equal to 1, then we go to shooting. And when the firing is 1, when firing is equal to 1, and when state is equal to 1, then we go straight to firing. Actually, we don't even need that second condition, but that's fine. And when state is equal to 0, when state is equal to 0, and when firing is equal to 0, then we go to idle. And when state is equal to 1, and firing is equal to 0, then we go to shooting. So let's just make sure all of this is correct. And check this. State equals 1, firing not equal to 1, firing is equal to 1, state is equal to 1. This is all good. So now we have a nice little tree. So all we'll do in the animations is make sure that the correct integers are placed where they should be. Okay, so let's first handle the animations of the arm. So let's go into the arm model, and actually before we do that we want to create a quick little gun model. So let's go into Blender and let's SZ to create a longer rectangular prism, and then edit mode, and we're just going to create a loop cut using Ctrl R, drag this up a bit, face select, and we're just going to extrude using E, and now we have a nice little gun. Nothing too complicated. We're just going to pass in the gun into the models over here. So when we go back, we have a nice little gun. So let's just scale this down a lot. And what we're going to do is we're just going to pass this into one of the hands. So let's go, and we have this hand over here. Just going to pass it into bone 001 and set the 000 to there. And let's go into the top view and just place the gun where it should be over here. Okay, nice. The gun is over here now, and we should have a nice little parenting system going on there. If it doesn't work, I will show you a way to fix it. Okay, so now that the gun is there, let's just lift this up a bit. Let's just see how the animations work. Okay, so let's go into the arm model, and we can see that the aim controller is set up. So let's create a new script. Let's call this the shooting script. Very simple stuff. We will make this more complex when we get into later parts of the episodes, when we get into different gun types, ammo, and all of those systems. But this is just for the third-person controller camera, okay? So we're just going to pass in the aim controller. So we're going to public animator aim controller. Private void update, and we're just going to handle all the input inside this update function over here. So if input.get mouse button down 0, so we're not using get mouse button, just mouse button down, because we can only register this event once. When we click, we don't want it to repeat over and over again. So aim controller.set integer, we're going to set integer firing to 1. So we're going to set firing to 1, and it should switch to firing if we are aiming. And we're also going to say, we'll actually draw the debug later. Actually, don't worry about that. And let's go else aim controller dot set integer firing is equal to 0. So if we have our mouse button down, then we are firing. If we're not, firing is equal to 0. Simple stuff there. And we're going to say if input.get mouse, and spell input.get mouse button down 1, then we're going to go into the aim state. So aim controller.set integer state is equal to 1. Okay, easy stuff. Else if input.get mouse button up 1, then our aim controller.set integer state 0. So let me quickly explain what's going on here. So when we put our mouse button down on 1, we go into aim. When we lift that, we go back to idle. And when we click using our left mouse button, we go into firing. And when we let go, we're off from firing. Very, very simple stuff there. So I'm just going to attach this to the gun right now. So let's attach this to the gun. And we're going to bring in the aim controller from the ARM model. Okay, nice. So before we go, I just need to make a quick adjustment. Let's go into fire and just go into speed and hit this to 5. So now it should go much faster. So let's see how this works in game view. So let's just select and go into aim and shoot, and we can see that we can shoot quite nicely. It's not as smooth as we would like it, so let's just increase the speed actually just a bit. Just see how this works, and that's quite nice. I like that it has a little bounce at the end, which isn't perfect, but what we can do to fix this is go into models, fire, and we did make a tiny bit of an error in this animation. We can see that we forgot to go to the very end of the animation, and we can see that now it shouldn't have that little jitter at the end. So let's check this out now and shoot, and we have a nice shooting animation. Okay, we can see that the arm model is on the side, so let's rotate that to face in the same direction as the player controller. Okay, so let's just see that the player is facing in this direction, so the arms need to be facing in that direction as well. So this would be on around -90, no, just 90 degrees, and it should be facing exactly in that direction. And I just need to make sure that the gun is actually following the arm model as it should be. So let's try that, and we can see that the gun is being pointed with the arms because it is a child. So let's see this, and we can see that no matter what the animation is, the gun follows the arm. So that's good now. So now we need to do the actual camera controller script, which where the majority of the coding is going to be today. Okay, so let's go into the main camera, and let's double click the camera control, and let's begin editing this. And like usual, let's set up the variables first so that we actually don't have to keep switching back and forth. Okay, so let's create a header and call this aiming vars, and we're going to create a new public vector3 player offset. So this is what Lobsang White was talking about when he said he wanted a player offset to the side. This is how you would do it, except we'll only be toggling the player offset when we hold the aim button. But for you, in your case, all you have to do is make sure that this player offset variable is always in effect, okay? And it should work perfectly. So I'll just teach you how to do the collisions in just a second. So public float distance from offset. So this distance from offset, like I explained in a few previous episodes, is what actually creates the orbiting. So every time we're at a point, our camera will be pushed backwards using a distance, and this will create like an orbiting effect around a certain point, which is the type of effect we want. We don't want to just be at a point looking up or down, okay? So I'll just show you this in effect once we actually begin coding it. So public transform rotator. This is the actual object that we're going to be rotating. So what do I mean by that? Well, we shouldn't be rotating both our arm models because this could change how the animation works. So all we're going to do is going to select the centroid object, and we're going to rotate this instead. And that should create a nice arm rotation effect anyway. So we're going to rotate the centroid, okay? So that's all the 3 variables that we need, and now let's begin actually coding the system. So before we code, I just need to make sure that we have a private void on draw gizmos function, and we just to visualize where this player offset is. So let's say vector3 r is equal to target dot transform point player offset gizmo dot color equals color dot red gizmo dot draw sphere wire sphere r 0.1f. So we're just going to pass in a transform point of a player offset. So what transform point actually is it turns local space into world space. So we can just pass in local coordinates, and it will always change it, always be relative to the player, no matter the direction it's facing or where it is in the map, okay? So that's a very handy function that Unity gives with the transform component. Okay, so we're going to create just a few changes to this late update function over here. So let's just scroll down and say if input.get mouse button down 1, we're just going to change the camera here. So we're just going to say transform.Euler-angles equals new vector 3 0 transform.Euler-angles.y transform.Euler-angles.z. So what's happening here is when we hit the mouse button for the first time, the aiming mouse button, our camera will reset its X rotation, which is the up and down rotation, which is this little red line, is the up and down. Let me just try and explain this. Up and down, right? It will reset this to 0 because if it's at a different direction, then it will create some weird offsets in our code, which we don't want. And we also need to create an if input dot get mouse button, not mouse button down, but get mouse button. This will be the update function for the aiming. Okay, and we're also going to create an else function. And this else will just encapsulate every other line of code that we created in this late update. Okay, so let's just fold that. Actually, before we fold it, we need to add a few lines to it. So in this few lines, we're just going to say rotator dot Euler angles equals new vector 3 0 rotator dot Euler angles dot y rotator dot Euler angles dot z. And this is the same concept as what we're doing here. If we're not using it, then we need to make sure that it's set to 0, okay? Because if this object is not set to 0, then the animations will play weirdly, and we don't want that, okay? So just make sure you add this line in the else function, okay? And here is where we're going to add the actual third person aiming code. So let's create a new function called third person aiming, and let's pass in this function over here, and let's begin coding the third person aiming script. Very, very simple stuff. It might be a bit like cheating to you. Just gonna copy all of this basically and just throw it into this function over here, and let's just remove this wall check because we don't want to check for walls, and we're just going to close off this function over here. We're going to remove this pitch locking, okay, and we're just going to shift tab to bring it backwards, and we're going to change a few variables here. First thing that we're going to change is this collision check parameter. So the way that you create the offset and still make sure that the collisions work is by changing this parameter here. This parameter, as I explained a long time ago when we created this, is the actual point, the reference point that the raycast is sent from the camera to make sure that nothing is colliding in the way. Okay, so if you change this, then the collisions will work, and also the player will be where you want it to be on the screen. So the actual function that we're going to pass in now is going to be target.transform point, and we're going to pass in the player offset like we have done in this gizmos function here, with one added part. Okay, minus transform.forward times distance from offset. Okay, so all this is every time we get this player offset point, okay, near the player, and we minus it by the camera's transform.forward multiplied by the distance that we pass in. And if we do this, right, no matter where we are, we'll be curving around this point. We won't ever be at this point. We'll be like behind this point or above it, but we'll always be orbiting it, okay? So this is the basic logic behind the aiming, okay? Now that we have all of this, we should just get right into the basic code. So we're just going to say transform.Euler-angles equals current rotation. We're not actually going to clamp the left and right axes like you might have thought that we might be doing. No, instead we're actually just going to pass in the entire rotation to the transform of the camera, but we are going to lock the arm, we're going to lock the arm axes, so it gives the illusion that we're locking the x-axis. So I'll show you what I mean. We're going to create two vectors now. Vector e equals transform.Euler-angles, and e.x is equal to 0. Vector 3, g is equal to transform.Euler-angles, and g.y is equal to 0. So these are two different takes on the camera Euler angles, but we're just going to lock each of these values. And all we're going to pass in here is we're going to say rotator .Euler-angles equals new vector 3 g.x, and we're going to pass in the rotator's other custom Euler angles. So let's just pass in these, And all we're doing here is we're going to set the X rotation of the arms, which is the centroid in this case. We're going to set the X rotation of this to the X rotation of the camera. So it can only move up or down, okay? It doesn't actually get the y-axis or the z-axis. It can only move x in the x direction, which is up or down, okay? And then we're just going to say target to Euler angles equals E. So the target, which is our player, will move left to right like usual. So this will create the effect of a third-person aiming system. So if we go back into Unity, and let's go into our main control camera, and we're just going to set up all of our variables. So in player offset, a nice value that I have thought works well is 1.5, 1, and negative 0.5. And a nice distance for offset is 1.75, and the rotator is, we're just going to pass in our centroid. And when we go in and select, let's go throw this in here, and when we click our aiming, we can see that we go to the side of the camera player, and we can go up and down, and we have a nice little aiming system right here, and it works perfectly. We can shoot, and we can do this. But one thing that I have found would work is if we change the transparency of the player, because this is a stealth game, we want to have as much view as we can. So all I'm going to do is I'm going to go down, and we have this little method called full transparency. I'm just going to copy this, I'm going to paste it again. We're just going to change this part, and we're going to remove that check for the if, and we're going to change this to just transparency, and we're going to give it a parameter of float t, and at this point where it says 1, we're just going to pass in t. So now we can just change the transparency to whatever we like. So when we click here under third person aiming, I'm just going to go transparency, and we're going to change this to 0.2. Okay, so this should just decrease the transparency when we are aiming. Okay, let's just check this out now. And we should have it to change, but it's not changing. I wonder why. Let's just check this. Huh. That's quite interesting. Let's go down and check what we need. And here we go. We can see that the if statement here is actually would be invalid all the time. So we won't actually be able to call this function. So just let's remove that if statement. Let's go up, and we should have a working transparency check right now. So let's just check this, and we can see that our transparency changes, and we can see through, and we know where we're actually aiming now. So we have the nice animations when we click, and now we have a nice system. And I want to show you that the collisions will still work. So let me just increase the distance from offset to around 6, and we can see that the collisions will still work quite perfectly even though we're on an offset. So I can set the offset to as much as I want. We can be on an X offset of this much, and the collisions will always still work. Okay, so this is perfect for any situation, any game. So I hope you guys enjoyed and learned a lot from this episode. In the next few episodes, I'll be improving the player, adding some shooting functionality, and I have a heap of stuff lined up for a proper stealth series. So I'm super excited, and I'm glad you guys have watched this. And make sure to subscribe if you enjoyed, and comment an idea if you have an original idea for this series. And I'll see you next time.